Hey guys, welcome to the second part of the 9192 video series. There was a lot in these two sections and I wanted to split it up. The first part was when you were given an angle measure and you needed to find the side ratios. In this section, we're going to talk about what happens when you're given the side values, but you need to find the angle measures. And in order to be able to find that, we're going to use something called trigonometric inverses. Now, an inverse by definition is like a function such that when operated upon produces a product of 1. So what does that mean when we're talking about trig functions? I'll tell you in a second, but you actually have worked with inverses a lot. Like a little example here would be like 3. The inverse of 3 is 1/3 because when we multiply them together, you get 1. All right. Okay, so when it comes to trigonomic inverses, you're going to see them written in 3 different ways. So the first way is this guy. So if you have the sine of x and you multiply him by 1 over the sine of x, of course you're going to get the value of 1. So that's one way that you're going to see the inverse written. The most common way, and the way that we are going to use, is the second one. It's with the -1 up in the superscript. So when you take sine, and this we call it inverse sine, you multiply them together, you get the product of 1. And then a trend in the last like 20 years you see a lot is something called the arc sine. All of them mean the same thing. You're going to use the same button on your calculator for all of them. But one of the reasons I'm most inclined to use this symbolism is because it's also what is written on most calculators. Okay, so when I use sine with the superscript of -1, I'm talking about the inverse. Okay, so just make a note of that. All right, let's dive in and look at an example. So let's say you're given a triangle, again, always a right triangle, and you want to find the angle measure here. And you have these 2 side values. Well, again, if we review SOHCAHTOA, which hopefully at this point you've written a lot and is looking very familiar, and maybe even you've memorized the relationships here, hopefully being able to identify the side relationships in the triangle have become somewhat easier. So again, in reference to this angle, we have the opposite side and the adjacent side. And the trigonomic function that corresponds with that is the tangent, right? So the tangent of x equals the opposite over the adjacent. All right, so let's go ahead and write that. So the tan of x is equal to 4 over 8. Now the thing is, we want to solve for x. Do not, under any circumstances, do this. The tangent function, or any of these trigonomic functions, are not algebraic values. You cannot do this. It absolutely doesn't work. It doesn't make any sense functionally. What we have to do is operate the inverse on both sides. So just like when you're solving an algebraic equation, you have to do the same thing to both sides in order to solve it. The same thing is true here. We have to operate the inverse to both sides. So then we're going to take the inverse tangent of 4 divided 8. Then over here, you're left with simply x because we've operated that inverse. We're left with the product of 1. 1 times x is x. And now we're almost good to go. So if you take a look at your calculator now, on any standard calculator that does more than just your basic operations, right above the sine, the cosine, and the tangent buttons, you should see little buttons, little words, either in blue or in white or in red sometimes, that denote this sign. The like tan inverse above the tan, the cosine inverse above the cos, and the sine inverse above the sin. All right, so in order to get to that function on your calculator, you have to hit the second button. So it's basically like your calculator can do everything on the buttons plus everything on top of the buttons. So you hit second tan, and on your calculator you should be able to see that sign, tan inverse 1. And now you can put in the value 4 divided by 8 and hit enter. And I think your homework assignment has you rounding to the nearest degree. So you should have gotten 26.56505 something something, which would round to 27 degrees. Okay, that is the value of this angle. So again, notice the difference here. When we're using inverses, we're finding angle measures. And that's a big difference from the last couple of days where we are finding side ratios, okay? All right, let's go ahead and do another example here. All right, so we have our SOHCAHTOA that helps us determine which trig function we need to solve for the angle measure. All right, so y here is my missing measure. And what side ratios do I have in relationship? Well, like I said before, I always like to start with the opposite. That's that guy. So 12 is the hypotenuse, and 3 has then got to be the adjacent. So in relationship to y, we have the adjacent and the hypotenuse, which represents the cosine. So the cosine of y is adjacent over the hypotenuse. So for our purposes, that is 3 over 12. Now, in order for us to solve for y, we absolutely will not divide by the cosine. We will operate the inverse cosine. So we have the inverse times cosine y. And that equals the inverse cosine of 3/12. All right, so now, again, these operate and get 1. And now on your calculator, if you do the second cosine, and then 3 divided by 12, you should get 75.5224, something like that. So that's going to round us to 76 degrees. All right. I think maybe you're catching on. Let's do another one just like this. All right, here's our missing value. We have the opposite and the hypotenuse values. So that tells me, according to SOHCAHTOA, the opposite and the hypotenuse, of course, leaves us with the sine. So the sine of x is 19 over 53. When I operate the inverse sine to both sides, I get an expression that looks like this. Then you get x equals, and you can plug that in and get inverse sine, which is 21 degrees. All right. So there's one more problem type. It's basically like we're going to put this all together. What happens if you have a right triangle and all 3 sides are given and they ask you to find a specific angle or 2? All right. So I'm going to show you 2 ways to do this. But the first is going to be exactly like everything we were just doing. All right. So let's say I want to find the measure of angle A. Here's angle A. Because I'm given all 3 sides, I can use any of the 3 trig functions that I want. So whichever one floats your fancy. I always kind of like the sine. The sine for me seems like the most simple. I don't know. It is the most common as you go through your mathematical courses. So I'm just prone to use the sine. But if you use any of them correctly, we will all get the same answer. So you don't need to worry about that. Okay, so in relationship to A, the sine is the opposite over the hypotenuse. So the sine of A is 24 over 74. And then in order for us to find A, we're going to operate the inverse sine to both sides. And when you do that on your calculator and round to the nearest degree, you should get angle A equals 19 degrees. All right, so now if they ask us to find angle B, you have 2 options. The first is that, do you remember when we have 2 values in a triangle, and it doesn't even have to be a right triangle, we can simply use the theorem that the angles inside a triangle have to add to 180. So I could just take 180 minus 90 minus 19 and get angle B. But I'm not going to do that. I'm going to use, let's use the tangent on angle B. So now here I am at angle B. And the tangent is the opposite over the adjacent. So 70 over 24. When I operate the inverse tangent on both sides, then I get an expression that looks like this. And then I'm going to get angle B, of course, is 71 degrees. All right, so just pay attention to your directions. Make sure that you're identifying your side relationships correctly and that you have a calculator, and you will be good to go. So finish up your notes, read through the examples again, and begin your assignment.